So hello guys, in this tutorial we are going to discuss on how we can plot a histogram using the R software. As you can see, I have a comment plotting histogram, and here I'll be using the hist function. This is the function that I'll be using in plotting a histogram. And you realize once I have the hist function and let's say a variable, say x, and I want to plot the histogram of the variable, or rather the vector x, you realize a convenient class will be automatically selected. However, we can change the class to another interval by having an additional information on the hist function. As well, when we have the hist function and the variable x, you realize the histogram will be plotted against the frequency of the data of the variable x. But however, we can also have the histogram in terms of the frequency density rather than the frequency by having some additional information in the hist function. So basically that is what we are going to do. So suppose we have a variable x, or rather a matrix x, and now x here is representing the age of women that are married in a certain village. So let's say we have x and representing the age, let's say we have 24 years, we have 25 years, 27 years, 26 years, 22, 23, 24, 25, 24, 25, 23, 26, 27, 28, 29, 25, 24, 23, 25, and so on. We can continue. So we want to plot the histogram of that particular data x. So when I say plot, I mean hist. The hist function, hist x, it will plot the histogram of x, that is the data of x against the frequency. So plot x, as you can see, the new console will open representing the age on the x-axis and the frequency on the y-axis. Again, you realize the class has been automatically selected down here, and by automatic we have the age against frequency. So we can as well have the output windows with us here and do some modifications here and there. So we are saying we want to have the breaks as specified, so we can go ahead and say hist. We can go ahead and say hist of the variable x, but now the breaks should be in an interval of let's say 9. Should be in an interval, let's say 9. And you can see here I have the histogram with the breaks of 9. As well, we can have the same histogram plotted against the frequency density. So instead of having the frequency, we need to have the density. So how am I going to do that? Basically here I'll have to specify and say hist x, and I'll say probability, because we know the frequency density is actually like probability. So probability equals true in order to have the density. As you can see, it has changed from frequency to density. So we have the histogram of the variable x against the density. So basically this is how we plot the histogram using the hist function. We can have some more examples. Suppose I have a data set. Let's say I have a data set. Now here we will generate some random data. So let's say we have a random data that is normal distributed, and we know when we are specifying a normal data or for a normal distribution, we need to know the number of the data set, that is the number of variables, as well the mean and the standard deviation. So suppose I have a data that is normal distribution, so I want to generate a random data that is normal distributed with a mean. Let's say it is having a mean of 5, and standard deviation SD of let's say 3, like that. As well, we need to specify the size n of the data. Let's say it is 100, like that, and we want to generate the histogram of that data. As well, we can call the data and see how the data is random selected. So this is the data we are generating of a normal distribution of 100 entities with mean 5 and standard deviation 3. And now we want to plot the histogram of this data, and here we'll go ahead and label the title, label the x-axis, and also try to color our bars of the histogram. So we'll go and say hist of the variable now is data, not x, and on the main title we can have on the main title we are labeling the main title to be histogram, the main title to be histogram, like that. We can label the x-axis, that is x lab, as we can basically call it x-axis, like that, x-axis, and we can go ahead and color the bars. So color is equals to, and we can give the color to be red, like that. Now we realize there are borders before the bars, so we can color the borders with a different color and say that borders, the borders to have the border to have what color? Let's say the border to have a green color, the border to have a green color, and we need to specify the breaks and say the breaks is equals to 10. The breaks is equals to 10, and we'll be having our histogram. As you can see, it is well labeled up here as histogram, and the frequency is indicated on the y-axis. On the x-axis is also labeled as the x-axis. So we can as well go ahead and change from frequency to density, and actually there are two ways to plot the histogram on density, or rather than on frequency, by basically adding this command, probability equals true, or we can go and say frequency equals false. We can go and say frequency equals false. So we'll be having the same, we can have the same like that, and here we add and say frequency equals false. Frequency equals false, and we realize when we say frequency equals false, it changes to density. So this is a histogram of the x values against the frequency density, which is as good as probability. Again, we can go ahead and have the density line drawn here. We can go ahead and have the density line presented here. How is that? After we have our histogram, we can use the line function. So this is the syntax of the lines function, like that. We have the syntax of the lines function, and then we specify the variable and say density. It is density, the line density of which data? Of the data that we have above there, and we can give it a different color and say color is equals to, let's say blue. Color is equals to blue, and we will be having our density line. As you can see, this is the density line, well presented on the histogram. So basically, this is how we plot a histogram on R software. We use the hist function. The hist function can be specified, the breaks, the probability. We can have it in frequency by not specifying that we need the probability to be true, or by not specifying that frequency is equals to false. We can actually have frequency equals true and have the frequency here. We can go ahead and have the density line, that is the probability line, by using the line function, the line function.